Eureka! I found a new element! What should I call it?
Wow, I think you should call it Beanium.
Why?
No idea. Just felt like it.
This doesn't all look the same. Let's take a look at this. I keep dropping this new element. It's okay.
They're bouncy.
Wow, look at these. I got these little crumbly ones. Kind of look like if they were old elements and all wrinkly.
They look like brains.
Yeah, those look like garbanzo element of some sort. These ones, these are little black beans, beaniums. What are these brown ones?
Speckled.
Reminds me of an old beat up car I used to have. Oh, Pinto. Yeah. And then these guys are huge. What color is that?
Yellow.
Yellow. So we got brown, white, black, and yellow. Now these are all beanium, but they're a little different. This one feels a little heavier.
It looks bigger.
It is bigger. Huh, interesting. So I've got myself a sample of this new element. Oh my goodness, where'd it go? I got it, here it is. Sample this new element called beanium. And we're gonna try to figure out the atomic mass of beanium because we're the first ones to discover this, Mr. Park and I. So exciting, we get to make this discovery. Huh, how could we possibly find the average mass of all these? Any ideas?
Well, we could count them.
I guess we could. You guys up for watching us count some beans? Okay. This is exciting. Are we really gonna do that? Okay, we're back. Whew, that was fun. So you can see we have 4 different isotopes of our beanium isolated. So we got to name this. So on your homework or on your lab sheet, we got to come up with a name for this. So why don't we call it BN for beanium, and then we'll call it white. So maybe we would call this BN-WH for white. Okay. And with those, Mr. Park, you were counting those, right? Remember how many you had?
79, I think.
79. Okay, so we had 79 of those atoms. Love it. We'll call this, these pinto beans, we'll call them brown. So let's go BNBR, right? And those, you counted, you had 75 of those. Okay. The big guys, the lima beans, we'll call them yeller. And those weren't too many of those. Those were just 16. And then this one was really fun. Very exciting stuff right there. The old black beans. Yeah. Oh, it's good. Good. They're kind of shy. Back off. Okay. And there were 201. I was lucky enough to get the opportunity to count all of those. Very exciting. Okay, so we need to find the mass of these. And we want to find the average mass of the entire element, beanium. Problem is we have to know what one of these individual atoms weighs. Now in the real world with real atoms, for example, every isotope of carbon-12 has the same mass. And every isotope of carbon-14 has the same mass. Not every garbanzo beanium has the same mass because, well, they're beans, okay? So what we need to do is we need to find the average of just the white. So easy way to do that, we know how many there are. Let's go ahead and take a plastic weigh boat.
Mr. Tro, why are you putting the weigh boat on empty?
Well, Mr. Park, if I just pour the beans in there, they're gonna go everywhere. So by putting the weigh boat in there, I have something I can put the beans in. But now I don't want it to say 2.356, so I'm gonna go ahead and zero that. Now all I need to do is transfer my white beanium sample into that weigh boat. We'll get the mass. So, total mass of the isotope, all the atoms is 40.595 grams.
So if they all weigh 40.595 grams, and we said that there were 79 of those white isotope atoms, that means we can figure out how much each one weighs by itself.
Yeah, each one doesn't weigh 40 grams, but all 79 total up to 40.5. So we should be able to find just a straight average. So you should be able to just find a straight average to get how much each one weighs. Maybe each one weighs a fraction of a gram. Okay? And since we have 5 digits in this weight, we should probably take this to about 5 decimal places. Okay? Let's do the same. What?
Then,
Okay, we'll cut.
you mean 5 total numbers?
5 total numbers, yeah. Which will be 5 decimal places.
Oh.
That's here.
Yeah, yeah, yeah.
Okay, so the brown then have a mass of 23.91, it says 915 now. The yellow beans have a total combined mass of 26.102 grams. Notice every time I write a measurement, I have a unit on it. Ooh, good solid transfer.
Well, it's not liquid.
It's true. That was solid. All right, so we got the black beans for a total mass of 47.847 grams. Okay, so now that we know, for example, that we have 79 white atoms, white isotopes, and they weigh 40.595 grams, you should be able to do a straight average like you've learned in math class. Take the total mass and divide it by the number of atoms. And you should be able to calculate a straight average for the average mass of each white beanium. And do the same for all the isotopes. We should probably take, since we have all these digits in our answer, we don't want to round yet, so we should probably take our answers to at least maybe 4 decimal places, or 4 total numbers, so that when at the end we can round it, and we're not only rounding once in the problem.